Alright, have you ever played this game? At a party, most likely. There's a jar full of candies or trinkets or marshmallows in this case, and you need to guess the number of thingies in the jar. And at the end of the day, after every single person has had a go at it, the person who made the best guess wins the game. Now, I am a data scientist and I'm supposed to have a way with numbers and an intuition. But between you and me, I have tried playing this game many times and haven't won even once. But don't judge me, okay? Because most people who make guesses and play this game are usually losers. Their guesses are way off the actual number. People are usually overly optimistic like I am, or they are overly pessimistic and underestimate the number of candies in the jar. But there's always this crazy lucky duck whose guess is dangerously close to the actual number of candies in the jar, and that person wins the game. Now, here's a little secret. If you were to take an average value, an average of all the guesses made by all the people at the party, then that average value will usually be really close to the actual number of candies or marshmallows in the jar. Okay? Why is this happening? Well, it's because when you're averaging the guesses, the pessimism and the optimism, they cancel each other out. And the remaining number or the resulting value usually is a pretty good guess. And this effect is called the wisdom of the crowd. Okay, let's get rid of the jar of marshmallows and try to understand how we can use the wisdom of the crowd effect in machine learning. I'm sure you must have heard of ensemble models. Essentially means you are bunching together different predictive models. For example, in random forests, you bunch together or ensemble decision trees, like a bunch of decision trees. And each decision tree is trained on a subset of the data, and it does a pretty good job if you ask it to predict on that subset of data. But the predictive accuracy fails or goes down when it tries to extrapolate the prediction on other parts of the data that it hasn't seen yet. So each individual decision tree or each individual predictive model is great on a certain subset of the data, but not so useful when you try to extrapolate the findings on all of the data. But how do we leverage the wisdom of the crowds effect? Well, all you have to do is, because you're bunching these together, the optimism and the pessimism, or in machine learning terms, the overestimation and the underestimation, the negative error and the positive error tends to cancel each other out. And the resulting average prediction is actually pretty close to the actual value. Now, this is true only when the rows of data or the different observations of data are uncorrelated with each other. By analogy, when you look at the guess the number of candies in the jar game, if all the people who are making a guess come from the same optimistic or pessimistic school or family, then the law of averages will not hold good. The wisdom of the crowds will not hold good. Okay? Now that is enough rambling about ensemble models and about the wisdom of the crowds effect. Now it's time to go and learn more about how random forest regressors and random forest classifiers work. Now it's time to go and learn more about other machine learning models.